Hi there, welcome to this course on getting started with the Java platform. My name is Matt Speak, I'm your instructor for the course, and in this course we're going to go through all of the kind of introductory things that you need to know about the Java platform to be able to get started. In other words, to start your kind of like developer career, if you like, with the Java platform. So a few things to say about this course. First off, this is a course for complete and absolute total beginners. So it doesn't matter if you've maybe had a little look at Java before, or if you know nothing about Java whatsoever. Don't worry about that. I take things completely from first principles. So you're not going to get stuck. You're not going to get into any kind of like issues where you're not sure how things work, because the course is going too quickly. Everything in this course is designed to be completely and totally for absolute beginners. I promise you it's absolute beginners. So you should be fine for this. So that's all well and good. But what's actually included in the course? What are you actually going to learn? So in general, you're going to learn three things you're going to get out of this course. And that's basically that we're going to get you set up with the tools that you need to be able to program in Java. So there's a certain set of tools that we need to get installed onto your system. So we're going to get you up and running with that, so you'll be able to get started and take it further. You'll have all the tools installed in your system by the end of the course. The second thing is that we're going to look into core concepts of Java. And when we say core concepts, we mean basically the absolute fundamentals that you need to know to be able to get started with the platform. So if you've heard terms like, for example, JVM, JDK, JRE, IDE, things like that, class files, bytecode, don't worry about all of that now. We're going to explain it all over the next few lessons so that you're familiar with those core concepts. And finally, the third thing you're going to get out of this course is you're really going to get a feel for Java. So by the end of the course, you're going to know whether you want to take it further, how it kind of feels to you as a programming language, as a development environment. I think you'll take it further because it's a really fun and exciting programming environment to program in. But at the end of the course, you'll know yourself and you'll be able to make your own decision. So those are the three things you're going to get out of this course. Get you set up with the tools, get you set up with the core concepts, and you'll have a feel to know whether you want to take it further. Okay? So if all that sounds good to you, let's get started. We're going to have a look at the Java platform as a whole. And we're going to basically see the core features of Java. We're going to see why Java's become so popular in the marketplace. Have a look at who uses it and what kind of features and benefits it gives us. And really, you're going to get a kind of like a flavor of the bigger picture, if you like, so actually what Java is. So let's jump in. So the first thing to know about Java is that Java is the world's #1 programming platform right now, today in 2021. And this is really quite exciting because it actually means that you're on the cusp of learning something extremely valuable, obviously with that marketable as well, but all of that as a package together, and I want you to realize this, takes you to the place right now where you're on the cusp of learning something really exciting and even potentially life-changing for you as well. Now, I don't say this lightly, but to be honest, if you want to have a career as a developer, as a software engineer, then pretty much Java is the best option for you at this particular time because it's been popular now for well over a decade. It doesn't look like it's going to change anytime soon with all of the different features that have been evolved, the marketplace share that it has, the kind of foothold that it has in the market. In other words, like all the different companies that are using it and that kind of thing. So this genuinely is a really, really, really exciting opportunity for you if you feel like you'd maybe want to go down that route of becoming a professional software engineer. Now, don't just take my word for it. We can look at a website. There's a website called, I'm not sure how you pronounce it, it's tiobe.com or tiobe.com. It stands for the importance of being earnest. And what it does is it tracks the popularity of programming languages by looking at the amount of web searches that people have done for that particular programming language and kind of plotting them in a graph, as we'll see. So if we just jump in now, I've got Chrome up here, the popular web browser. If I just jump into tiobe.com, here we can see we've got the website for it. And right over here on the right-hand side, you'll see this tiobe index. So if we click that and we just scroll down, you'll see that there's a graph at the bottom of the page. So here we are. So this graph is basically charting the popularity of the most popular programming languages that there are today. And you can see it's giving, you've got C, Java, Python, C++, C#. These are different programming languages that you can choose to develop software in. The main thing that I want to point out here is that if we click on one of these, specifically click on the Java one, then from this you can clearly see by looking at the line graph that's highlighted, which is the one in black, which is the one for Java, you can clearly see that Java, pretty much in general, is ranked over and above any of the other languages. So while there might be some contenders for that kind of #1 spot, namely with JavaScript and Python, which you may have heard about, in spite of this, Java is still pretty much #1. And it looks like it's going to continue that way for quite some time. So just know that what you're actually learning in this course, when you're establishing the beginning of that journey as a Java software engineer, you're learning something that is very marketable, and ultimately going to be very profitable for you as well for the foreseeable future. So I just wanted to point that out, first of all. So we've seen that Java is the #1 programming language today. The next question you probably have is, well, okay, who's using it then? Well, pretty much all of the big players today use Java as a development platform. And so if we go through some of these now, Google use it. So you're obviously familiar with Google, the popular search engine, the most popular search engine in the world. That uses Java on the back end to power its products. Amazon, huge e-commerce store, the biggest e-commerce store in the world, they use Java too. And why would companies like Google and Amazon choose to use Java? The reason for that is because of Java's so-called scalability. What that means, I won't go into it too much, but what it means basically is if you think about it, with Amazon or with Google, you have pretty much millions of people at any one time who are making requests on the website. So for example, in Amazon, they're looking up orders, looking things up in the product catalog, making orders, changing things, getting recommendations, all that kind of stuff. Millions of people at the same time are using that website. And this is possible because of the power of Java, because of its scalability. With Java, you can pretty much kind of like chain different Java processes together, kind of like grouping a whole load of computers together, if you like, so that the total combined power of all of those computers together can be used at the same time to be able to deal with all those millions of requests. So that's pretty much the power of Java. So it's an incredibly powerful language, and it's something, in fact, the main thing, that's the reason for its popularity at places like Google and Amazon. But it's not just search engines and e-commerce sites, we also have streaming services as well. So for example, Spotify, the popular music streaming service, that uses Java. In addition, Netflix, they also use Java as well. And the reason they use it is because, again, it's about Java's scalability, this aspect that it can be very powerful and can service multiple clients. That means multiple people on their different devices, millions of those people at the same time. But it's not just limited to those companies either. If we look at social media, for example, we'll see that Facebook uses it, Twitter uses it, LinkedIn uses it, Pinterest, and Instagram use it as well. So by now you should be getting a real picture of the scope of Java. You know, Google, Amazon, Spotify, Netflix, all the social media companies, Facebook, Twitter, LinkedIn, Pinterest, Instagram. I mean, this is huge. It really is huge. If you ever want to get into something, or rather some form of technology that has a future, Java is the thing to be getting into. So it's good that you're on this course to make those first steps into that Java development career. So all these big companies use it. Where is it used then? Well, various different places. It's used in mobile phones and tablets. The Android platform, for example, is based entirely in Java, and so therefore Java is the backbone of all Android devices. But not just handheld devices either. We also see Java in huge cloud-based applications, powered by hundreds of different servers at the same time. A server is just a fancy name for a computer that allows a website to run, by the way. But we see Java used there as well, and that's because of its power that we've just seen. In fact, Java powers 3 billion devices all around the world, which is pretty phenomenal if you think about it. 3 billion, that's a massive number. So on 3 billion different devices all around the world, Java's running, providing this powerful backbone for all these devices across the world globally. Pretty exciting stuff, I think you'll agree. So if everybody's using it, and Java's so popular, why is it so popular? Well, there are a few reasons for Java's popularity, and let's just dip into a few of them now. If you don't understand all of these, don't worry, I don't expect you to understand them, but we'll just give a few bullet points of what makes Java just so popular. So first up is platform independence. And what this means is that Java has this idea called write once, run anywhere, which we'll see shortly. And that means that you can write a program once for one machine, for example on Windows, and then you can run it on all of the different machines. So you can run it on a Linux machine or a Mac or a Unix server or wherever else. And so we have this notion of platform independence, which is a hugely powerful concept. It means that effectively you don't have to rewrite the same software. In other words, reprogram your application, that is. You don't have to redo that for each different machine type. So for example, supposing I write an application on Windows and then I want to release it, I have the ability then to release it on Mac and on Linux without having to reprogram the whole application in Mac or reprogram the whole application in Linux. So that's the first thing, platform independence. Now, the second thing pretty much is the thousands of libraries that we have. So in Java, there's this whole kind of software movement called open source. And in a nutshell, what that means is that people have already written components. Those are kind of like mini applications, if you like, which you can assemble together to make your own application. People have already created all of these libraries, all of these different components. And there are literally thousands of them, and they're available completely for free. Now, what this means to you is that you don't have to write that code. It's code that you get for free. You can just incorporate that code into your applications and use the features which that component gives you. So very powerful, very beneficial, having this idea of so-called reusable components. That's another key benefit of Java as well. Additionally, as we've seen, we've got the versatility of the platform, the fact that you can write applications which run on a mobile device, small scale, so just for an individual user, or you can write applications which are designed to be used for millions of users using Java in the cloud. The cloud, by the way, is just a fancy term pretty much of saying that you have hundreds or thousands of computers all working together to do one particular thing or execute one particular program, which in the case of Amazon, for example, will be its website. Don't get hung up on the idea of a cloud, but that's just basically what the cloud means. So yeah, Java has this versatility to be able to run on one device or on hundreds or thousands of devices at the same time. Very powerful, and very beneficial for companies as well, since they can build huge e-commerce stores like Amazon we've seen. Another aspect to Java's popularity is the market share that it has, kind of like the foothold in the marketplace. So because so many different people use Java, so many different companies rather, use Java, plus as well because it's been going for 25 years now, I think it's about 25 years, I think it was 1996 when it came out. Because of that, it means that there are a lot of skills on the marketplace, people who know Java. It also means, because we have so many different companies using it and different developers using it, there's a very lively kind of community and a huge source of documentation, Java technology itself, which is also really, really useful. Which also brings us to this idea of the developer ecosystem. That's basically all of the tools and technologies that surround Java itself that have been developed to make your life as a Java developer much easier. So all of this together as a package for you personally means that Java's got a bright future. It's got tremendous job opportunities and market opportunity for you personally. It's pretty easy to use and versatile to get pretty complex stuff programmed quickly and easily because of all of the different libraries that you have as well. And there's a ton of documentation out there and useful tools which can help you get started. So that's an overview of the Java platform itself. Now let's have a look at the Java language, which has also been central to Java's success. So the reason the Java language is so popular, which is pretty much the heart of the platform itself, comes down to a few key reasons as well. So first up, we have the fact that it's pretty simple to use. It's simple to use, it's easy to understand, it's got less of a path, or rather less of a learning curve for you when you get started. So it's a pretty accessible language to be able to just pick up and start to get started with. So that's one of the key benefits. Also related to that notion of versatility that we've seen earlier is the idea that it's object-oriented. So object-oriented is a kind of a style of programming. You have different styles. There's functional programming, procedural programming, object-oriented programming. We don't have to go into detail about those right now. But in object-oriented programming, you basically program objects, and these different objects interact with each other. And it's basically a very powerful way of being able to quickly write systems which are easy to understand, easy to develop, and easy to maintain and extend. Okay, so moving on, another aspect of Java is the fact that it's fully rounded. And what I mean by that is that it gives you access to be able to do everything you'd want to do pretty much with a computer. So that means, for example, being able to access the computer network, access disks, files, folders, that kind of thing, as well as interact with desktop. So that means, for example, drawing windows and buttons and having drop-down menus, all that kind of stuff. Java's pretty much got APIs for all of that stuff completely out of the box, which means that you don't have to write that kind of stuff. You can just reuse the existing code that the Java platform already gives you to be able to access networks, read files, write to files, construct windows with text boxes and buttons on, all that kind of stuff. So that's been a good high-level overview of the Java platform. As you can see, it's a really exciting platform to program in, and you're probably really excited to get started now, which we'll do in the next video. We're going to look at the Java platform itself. Specifically, we're going to look at the key components of the Java platform and see how they all slot together. Let's dive in. Now, before we start, I just have to give you a quick word of warning about Java. In Java, just like any form of technology or any form of programming, it's not specific to Java, this is any form of programming or anything to do with IT, there are always going to be lots of acronyms, so those are abbreviations for things. You're going to hear things like JDK, JVM, JRE, things like that. Don't worry about that, we're going to define those shortly. It's just a word of warning about that. And also, not only acronyms, we're going to have a lot of terminology as well. So we're going to hear terms like bytecode, source code, class file, compilation, those kinds of things. Again, when you first hear a word that sounds technical or you come across these abbreviations, it can seem kind of daunting because you don't know what the acronyms and terminology means. But don't worry about that. Don't be dissuaded. Don't be put off. I'm going to explain all of these in this course. I just want to give you that quick word of warning. So yeah, above all, don't panic. That's the key thing. Do not panic. All will be explained. Now let's start off with the key point about Java, which is this notion of platform independence. Java has this idea of something called WORA, W-O-R-A, which stands for Write Once, Run Anywhere. And this means that you can take a Java program and you can run it on multiple machines. Let's have a dive in now and see exactly what this means together. So let's start with my Mac. So I have a Mac Air, and let's suppose I develop a program on my Mac. And then I go to work, and I think, do you know what? I could actually use this piece of software, I could use this code that I've written, this program, I could use it on my work laptop as well. But at work, I've got a Windows machine, and these are two completely separate types of machine. One's a Mac, one's Windows. Now to you, they might just be computers, and that's fair enough, they're just laptops or desktop machines. One's a Mac, one's Windows. But fundamentally, these are completely different machines. The key part of that is that, for example, if I use an application on a Mac, for example, Adobe Photoshop, then I can't use that exact same application on Windows. It's true that both Mac and Windows have a version of Photoshop which they can both run, but that version is completely different. One has code for a Mac, the Mac program code if you like, and one has code for Windows, the Windows program code. And the actual code that each installation file will contain is completely and totally different. And the reason for that is that these are completely and totally different machines. We don't just have Macs and Windows-based machines, you can also have Linux-based machines. So for example, when we spoke about cloud computing earlier on, or if you look at large-scale websites like Amazon, the e-commerce site for example, you'll find that what powers those websites are hundreds, if not thousands, of these so-called server machines. That just means a computer without a screen pretty much, which has super fast hardware or electronics inside to be able to power these huge e-commerce applications. You also have those as well. And again, Linux is a completely different type of machine than a Mac or than a Windows machine. So given that we've said that if you have an application or a program on one machine, like a Mac, and it's not possible to run it on another machine like Windows, how does Java do this then? Well, let's take a look inside and see what happens. So let's take a look at actually what's inside the Windows machine. So inside that machine, first off, we have an operating system. And the operating system is a foundational computer program, if you like, which tells the computer how to run. And what I mean by that is that if you didn't have an operating system on, for example, a laptop or a desktop machine, then you wouldn't be able to load any programs onto it. You wouldn't be able to access the internet. You wouldn't even be able to switch it on and have it do anything meaningful. You'd just switch it on and nothing would happen. And that's because all computers need an operating system installed on them, which is kind of like the super program of the computer, if you like, which tells the computer how to run. So for example, it tells the computer how to access files, how to access the network, how to display stuff to the user, how to print to printers, that kind of thing. That's what an operating system does. And we have three different types of operating systems. We have operating systems for Windows, Mac, and Linux, which is why we started off with those three machines initially. So once you have an operating system installed on your machine, that means you can actually start to run other programs on it. So for example, on my Windows machine at work, I can run Microsoft Word, edit some outlines for a course, for example. I can also have Google Chrome running as well, do some web browsing. Maybe I have Outlook as well to be able to access email. And I can do all of those three things, execute those three programs at the same time, thanks to this operating system that we have. And also underneath the operating system, by the way, is the microprocessor. This is the actual chip inside the computer itself. I've kind of grayed that box out because we don't really need to know anything about the microprocessor, apart from the fact that having an operating system means that the three programs at the top, Microsoft Word, Google Chrome, and Outlook, they don't need to concern themselves with the different types of microprocessors. So in this way, the operating system kind of shields those programs away from the much deeper complexity of the actual chip inside the computer itself. But in addition to these programs, if we're looking at Java, we can also install another program, and that's known as the Java Virtual Machine. Now, the Java Virtual Machine is really where all the magic happens, because it's this JVM, the Java Virtual Machine, it's the first acronym there, that allows us to run different Java applications. So looking at the JVM, once you have a JVM installed on a given machine, that means that you can run first Java application on it, you can run your other Java application on it, and again, another Java application on it. So the JVM gives us a facility then to be able to run Java programs. That's the key point here. Now going back to these three computers we saw before, you can have different operating systems on them. So if you have a Windows machine, you might have Windows 10 on there, Windows 8, Windows Vista, Windows XP. Those are different versions of the Windows operating system. If you're on a Mac, like I am, you'll have Mac OS 10. And on Linux servers, you're going to have something like Ubuntu, SUSE Linux, Red Hat, or Fedora. The key point here, though, is that these three machines each have installed on them different operating systems. However, because each of these machines, or specifically each operating system, has a JVM available for it, that's the Java Virtual Machine special application we've just seen. So there's a JVM for Windows, a JVM for Mac, a JVM for Linux. Because of this, that means that the Java program that you write can then run on each one of these machines. So this means you can write your Java application on a Mac, then run it on Windows, or you can write the Java application in Linux and run it on the other two machines, Windows and Mac. It really doesn't matter. And that's really the power of this so-called WARA, or this write once, run anywhere. The fact that Java gives you the ability to be able to do that. So you write the application once in Java, and then it can run anywhere you choose to put it. Now, there are a few other acronyms as well, which we'll just quickly go over. We'll get to see these a bit later on too. The first one is the JRE. This is the Java Runtime Environment. And this is basically effectively the package that contains that JVM. So when we saw the JVM just now, which was sitting on Windows, Linux, and Mac, that JVM actually comes as part of the JRE, the Java Runtime Environment. And that's a key there as well, is the Java Runtime Environment, because you're running programs. So because it's the Java Runtime Environment, that's where you'd expect to find this JVM, because the JVM's responsibility is to run those Java programs. We also have the JVM, which we've seen, the Java Virtual Machine. Yep, that's the thing that runs those programs we've seen. And we also have bytecode as well. So bytecode pretty much is what the JVM runs itself. It's kind of like the language that the Java program is turned into, which the JVM can then understand. We'll see this in a little bit later when we look at compilation. But what I mean here is that the JVM as a program, which runs Java programs, needs to take an input. It takes an input file. That input file contains the programming commands to tell the program what to do, for the actual program code itself, and that program code, that is bytecode, packaged in so-called class files, which we'll see a little bit later on too. So who creates the bytecode? Well, what creates the bytecode is a thing called the compiler. So just to recap, we've got the JVM, which runs the Java application. The Java application is a file called a class file. That class file contains bytecode, and the thing that produces the bytecode is a thing called a compiler. So the compiler's job is to basically take your Java program and convert it effectively into instructions that the JVM can understand. And it does this by taking the program you write in the Java programming language, and that's known as source code. So you write source code, the compiler takes that source code written in the Java programming language, converts it into bytecode in a so-called class file, and then the class file displays as input to the Java virtual machine, and the Java virtual machine executes each instruction inside that class file, the bytecode, to actually do what you've programmed it to do. Now, this might seem like a whole lot of stuff to take in, and indeed it is. So let's jump in now and look at a tangible example. Let's bring it down from up in the air and actually look at this process firsthand and see how we actually compile a Java source file into bytecode itself. Okay, so let's jump in now and see actually how we can compile a Java program, our Java source code, using the Java compiler, or Java-C as it's also known. I'm on a Mac. There's a program called Terminal. So let's just see how this process looks. Now, first off, don't be fazed by the fact that I'm typing some commands into this big black window. When you actually do Java programming, you don't have to do this. So what I'm about to show you is really the nuts and bolts of what happens with Java when you're compiling a Java program to its bytecode. But I'm just doing it for demo purposes. So you won't actually have to do this yourself. So don't worry, you won't have to type these types of commands. And it may look complex, but it really isn't. I'm just showing you actually the lowest possible level, pretty much at the bare metal kind of like level, what this Java compilation is all about. Now, we could actually do this in a text editor. That's a small program that allows you to type in text and save it to a file without any formatting, so without any kind of bold or underline or italic instructions in that file. This is just a nice simple way to be able to quickly create a file using a command. And for the purposes of this demo, it's fine. You won't have to do this in general, so don't worry about it. So that said, if I'll make a new folder, demo, and I'll go into that directory, and I'll quickly create a file with this special command, and I'll just call it app.java. And what this means is that I can just basically type in code here, and it'll create a file, which is going to be the Java file, which will then compile, and then see what actually the Java compiler spits out. So if I just type some Java code here, a public class app, and then we're going to define a main method underneath. And this method, public static void main, which takes a so-called array of string parameters. This is the standard method that you'll find in any Java program, which is where a program starts off, so-called entry point. But again, don't worry if this looks complex for now, because we'll cover this a little later down the line. And then here, I'm just going to type in this instruction, which basically prints out hello world to the screen. It's that system.out.println line you can see there. And just finish that off with some closing curly braces, and press Ctrl-Z to end that. You don't have to know what this code means, but just know if I clear the screen, I print out app.java, just know that this code is the simplest possible Java program you can write, and it's a Java source file because it has a .java so-called file extension. In other words, this is the file name here, app, but its extension, which is this thing that starts with a dot, this is .java. It's a .java extension. So this means it's a Java source file. So how we compile that is we use Java-C. Java-C stands for Java compiler, and we pass that Java file into this program. So when we just write out a command like this, Java-C, it means it's going to run that program. So now it's running the Java compiler program. We'll do in a second rather, and it will take as input anything that we put after it. So here we're saying app.java is the input into Java-C, which is the Java compiler. If I then hit enter, see it paused briefly then for a second, and that's because the Java compiler was actually taking this app.java file and producing the output file. If we now look, we can do with this command, the contents of that folder, that directory, we'll see that we have our original app.java, which we created, which is this file here. But we also have now another file, which is app.class. This is the class file that we spoke about earlier on that contains the actual bytecode that's then runnable by the JVM. So now that we have that bytecode class file, let's see how we run it on the JVM. So again, let's have a look at what we've got in the directory. Here we've got .java, which was the program that we started with. That was our Java source file. We've got app.class, which is the class file the Java-C compiler produced. It's what it output. So it took in the app.java source file. That's the program code that we wrote. And it converted that into app.class, which contains the bytecode that's going to run on the JVM. So all we need to do to run this is we have another command, and the command to launch the JVM itself is Java. So whenever you see Java, this is the JVM. Whenever you see Java-C, it's the Java compiler. So this command here means run the JVM, and again we pass the input that we want that program to take. And you might think we put app.class, but we don't, we just put app. And what this does when we run it is it's going to launch the JVM, so the Java virtual machine is going to be running, and it's going to look for class, which is the main kind of unit of code in Java. And it's going to look for a class called app inside this current directory. So because we have this app.class file here, it's going to find that, execute the bytecode, which is inside it. So if we run this now, here we can see it's running hello world. So yeah, that might seem a little bit technical. And like I say, it's something that you won't actually have to do. You won't have to go into a big black box and type in those commands in the terminal like I did. But I just wanted to do that so it gives you a good idea of actually what's happening behind the scenes. And it turns out there's a tool that can do that for us really nicely, which looks good. It's got, a proper window with drop-down menus, and it's a proper application, in fact, and that's called an IDE. But we'll see that a little bit later down the line. When we write a program in Java, that's the source code that we're writing. Just to summarize then, and we can do that, as I say, in a thing called an IDE, which we'll see shortly. And so the source code is what we write. It's the source of our program. That's why it's called source code. And that's in the Java programming language. And that's converted into bytecode, which is in this class file. That contains the instructions which are interpretable by the JVM, which is the Java virtual machine. And as we've just seen, how we get from source code in Java to the bytecode in the class file is by using the Java compiler, which is this Java-C tool we saw. So that should give you a nice overview of how the main components of the Java platform slot together, and just a sneak peek into how we can compile and run the Java program using the Java compiler, which is part of the JDK, and the Java virtual machine, which is part of the JRE, but also bundled with the JDK as well. We're going to move a bit further, and we're going to see how we can actually install the JDK itself onto our own machines. So the JDK, remember, is the thing that has Java-C, which is the Java compiler, which is the thing that takes our Java source code and converts it to bytecode. And then that bytecode is then run on the JVM, which is the Java virtual machine. And there's also a JVM, which is bundled inside the Java development kit, which is the Java command we saw as well. So let's jump in. So in order to install the JDK, we need to do 4 different things, really. First off, we need to work out which version of the JDK we need to install. So that means basically we need to download the right JDK. So if it's the JDK for Windows, download the Windows one. If it's the JDK for Mac, download the Mac one. But even amongst the individual operating system, there might still be some choices, which we'll see. Next, we need to download and run the installer. This is a really quick process to do. It's literally just kind of double-clicking. So that'd be nice, simple, and straightforward. Next, we need to set a thing called an environment variable, which is going to be called Java_home. Now, environment variables, it might seem it's getting very technical now. It's really not. It's basically just a way of letting other tools which work with Java itself, it's a way of letting them know where you've installed the JDK to. And we do that through creating this thing called an environment variable, which is very simple to do and straightforward, as we'll see. But it just basically makes that piece of knowledge, knowing where the JDK is installed, just exposes it so that anybody, or any other applications rather, which are running on that machine can take a look at the environment variable, access the path or location of where we installed the JDK to. And finally, of course, we need to test that it actually works. So first off, let's look at how we can work out which JDK version to install. So I'm going to do this on a Windows machine for this particular demo, because that's probably the most popular operating system with people who are watching this course. So the first thing you need to do is to find out if you're using a 32-bit version of Windows or a 64-bit version of Windows. Really easy to find out. Just go down here to the Start menu and go to the little cog, which says Settings, and then go up to System. And then if you scroll down to the bottom, you'll see About. So if you just click About, it'll tell you about the system. And here you can see at the bottom it says 64-bit operating system, x64 based processor. So this tells us that this particular system is running Windows 64-bit. And also, if you notice, you'll see this x64 here. Just remember that for a second, because we'll actually see this in the version of the JDK that we want to download. Anyway, so we can close this now with the X. So just go down here into search box, and we're just going to type in Internet Explorer. Just the first few letters will do, as you can see. So here we've got Internet Explorer, so we'll just click this. And if we just type in here, Java JDK download, and you can see that it's showing us here The first link, the primary link, is the one that goes to the Oracle website. And this is basically for all of the downloads. So all of the different versions that you have with Java, this is the page that you can get them from. But we want to have a specific version. We want to go for Java 8. And that's because it's a lot easier for beginners to work with Java 8 than it is to work with the latest and greatest version, which is Java 15. So if we click on Java 8, JDK, accept cookies. And so here we are on the Java 8 JDK download page. So if we just scroll down, you'll see here that the version we're going to download is this 8U281, which is basically the latest version of the Java 8 version of the JDK, which is the one we're after. And then if we go a bit further down, we can see we've got Linux here, we've got macOS, Solaris, and right at the bottom, we've got these two options here for Windows. Now at this point, we need to know whether we have a 32-bit version of Windows or a 64-bit version of Windows. So there are two different versions of Windows that you can have, 32-bit and 64-bit. And these are denoted by x86, means 32-bit, and x64 means 64-bit. You wouldn't necessarily expect that. And this is actually a reference to the underlying microprocessor. But just know that the 64-bit version one has 64 in it, and the 32-bit one doesn't. So we've checked already on this particular version of Windows, and we know that it's a 64-bit version that we need. Because if you remember, that's the x64 that we saw before. So let's download the 64-bit version now. So if you just click on this exe file, and we'll just accept the license agreement, clicking that checkbox, and then just click this download button here. And so, unfortunately, when you download the JDK, you have to have an account with Oracle. It's free to sign up, so if you don't have an account, you can create this, use this create account button down there. But I already have an account, so I'll just put my details in. And then just hit sign in. Then you can see here now, it says do we want to save or run. So I like to save it to the downloads folder, and then I can run it from there afterwards. I'm not bothered about saving the password either, so I'll just click not for this site. So now you can see it's downloading. It doesn't take very long to download. It's not that big, to be honest. And also I've got a pretty fast internet connection as well. Almost there. Runs a security scan. And it says it's completed, which is good. So then if we hit this view downloads, we can see here that it's actually in this downloads folder. We also hit this button here. It'll open up the downloads folder itself in Explorer. So I prefer to run it from there. So if we just kill this browser, and just this one too, then we want to run it from here. So you want to right click and you want to do run as administrator. And that's important because it needs to make some entries into the Windows registry, which needs administrator permissions. So if we just click yes to this so that you can make changes to the system. Now we're just going to click next here. And then we go to the next screen. And on this screen, we can see the items that it's going to install. So it's going to install the development tools, also the source code of the actual JDK itself, which is interesting to look at as well, although it's outside the scope of this tutorial, but it's definitely useful to have a dig into that at some point if you're curious. Plus as well, we've got the JRE, which we'll also install. So just accept the defaults here. You could customize the folders if you wanted to, but that's fine. We're just going to accept the defaults for now. That's okay. Just click next. And then we can see it's just installing. It's pretty quick, to be honest. Copying the new files across over. And at this point here, it's offering to install the JRE for us as well. So you can just click next to that also. And it's just going to run through that part of the installation procedure as well. Again, it's pretty quick. You can see here that Java's been going for 25 years as well. So it's a really stable and rich platform to work on, which is why it's so popular. At this point, it's been installed. So just click close there. So now at this point, if we go into the C directory, which is under this PC, and we look inside this program files directory, under Java, then we can see here now we've got two folders, JDK and JRE, the version 1.8. So this is basically the JDK, the Java Development Kit, and this is the JRE, the Java runtime environment that we've spoken about before. Just quickly, while we're on the topic, let's just have a quick look inside. Inside the JDK, you'll find a bin subdirectory. Subdirectory means a directory inside a directory, and these are all of the tools, if you like, which you have access to as a Java developer to help you write Java programs. But the main ones you're interested in are Java-C, which is the Java compiler we've seen, and Java itself, which is the Java virtual machine. Now, the next step we need to do is we need to, if we just go back out to that folder above, we need to basically put this folder here, which is the folder where we've installed the JDK to, we need to put this in this so-called environment variable. So let's see how we can do this now. So first of all, if I just double click this, then I click into the address bar here, just go over here and just right click and then click copy. So what I've done actually here is I've just basically put the contents of this, so the directory that's highlighted, into the clipboard, because I'm going to use it later. I can just cancel this out now, and then I can go into this one here, this PC, into properties, which is actually an easier way of being able to set this environment variable. And then if we go into advanced system settings, you can see here, you click on that, and then click into environment variables. Now, what we're seeing here, this is basically the set of environment variables which are configured for this particular system. So the concept of an environment variable isn't just specific to Java or even specific to Windows. It's a concept which is available in all operating systems, and it just basically provides a little place in memory where programs can look in to get a piece of data they need to share. In the case of the Java tools, that's the JDK installation path, and that's what we're going to set now, but there are other ones too. The most important one being path itself, which is the one you can see here, which we'll come to in a second. But first of all, let's create our Java_home. So if I click new here, then go Java_home. If I press tab, that gets me into the text box below. Now if I just do Control V, paste it, then you can see it's here now. Now also, if we just put that in quotation marks, the reason being is that Windows is a bit funny if you have spaces in a path. That's meaning the actual descriptor of where the folder is, which is this thing we're looking at here, it's a path. You can see here we've got this space between program and files. So just to protect that, we basically put a quotation mark here and a quotation mark there, and then that kind of like packages it all up, if you will. So if we just click OK now, so now we've got Java home set. The final thing to do is to double click on the path variable to change that. And we're going to add a new entry here, which is Java_home with these percentage signs at either side. And that basically means resolve this to the actual value. So Java_home is the variable, that's the name of the piece of memory which holds that data. But to get what's actually in that piece of memory, we can put percentage signs around it. It's known as dereferencing that variable to get the actual value out, and then put \bin and enter. And the reason for that is because, remember, we've just had a look in the JDK directory itself, and we then had a look in the bin subdirectory and we could see all those tools. Or by putting this in here, adding it to the path, this is going to allow Windows to locate those Java tools for us. So basically, whenever you enter a command in a DOS prompt, which is something we'll see in a second, one of those scary black windows, which isn't that scary in fact, but it might appear so at first, but it is really not. Whenever you enter a command in there, what actually happens is Windows goes through each one of these folders in turn to look inside that folder to see if that command exists in that folder. And when it finds wherever the command exists, then it will execute it. So we're just going to move this up this a few times, and that means that the first place that we're telling Windows to look is definitely going to be in this Java home directory, Java home bin directory rather. And the reason for that is because, unfortunately, Windows actually comes with a JRE to be able to execute Java in the browser, and that's actually stored in this path here. And by putting this Java_home bin before that, it means that we're going to get our version of Java, which is part of the JDK, which we've just downloaded. So if we click OK to this, and OK to this, and let's close some of these windows, we're going to go into the command prompt, or this DOS prompt. If you type cmd, you'll see here we have this command prompt. Click on that, and now we're in a thing called the DOS prompt, or as it's now known, the command prompt. And it's called that because it's prompting you, prompting meaning to ask. It's asking by virtue of the fact this thing's flashing, this cursor's flashing here, it's asking you for a command. It's a command prompt. Makes sense, yeah? So if we type setj, which is a command, and hit enter, this is going to show us the environment variables which have been set, which start with the letter J. And you can see here we've got our Java_home environment variable that we set. If we were to do set P, then we'd see all of the variables which start with a P. And the first one we can see is path. And now we can see here that we've got the Java home environment variable we saw before. It was being dereferenced by those percentage signs, remember, with a /bin after it. That means the subdirectory inside there. If we now type in Java-C for the Java compiler and do version, then we should get a message back which says it's the 1.8 Java compiler. And the reason we're doing version is just it's a nice, quick and simple way just to verify that a given command has been installed properly, which in this case is Java-C. And we can do the same thing for Java as well, which is the JVM. That means that we've got the JDK set up correctly. And just to double check that as well, we just check the Java version. And similarly, we also have the same version here. So these two versions match now, 180.281, 180.281. Which is fantastic. So here we've got the Java compiler, then we've got the Java virtual machine. Don't forget, if we hadn't have put that entry to be first in the list, then we wouldn't have seen that version here, because it would have been picking up the Java version from this one here instead. Anyway, at this stage, we're all set up and we can actually start to develop Java applications on this Windows machine. We're going to take a look at the IDE. That's an integrated development environment. That's basically a tool that you can use to write, compile, and run your Java programs, which no programmer will ever be without. So let's jump in. Now, there are two different IDEs on the market currently. When I say on the market, you don't have to buy them or anything, but I just mean those that are available to you in general to download. Now, both of these are free, or at least have versions that are free, and we'll just have a look at both of them now and compare them. So the first one is Eclipse. So Eclipse has been around for a really long time. It's from the Eclipse Foundation, and it's a really good IDE to start off with. The other one we've got as well is IntelliJ IDEA. Now, IntelliJ IDEA actually has two different versions that you can get. It's got a community edition, which is the free version, and it's also got another edition called the Ultimate Edition. And that's a paid product, which typically you'll find in corporate organizations. So in other words, in corporates where you have a professional Java development team, if they're willing to spend the money on the IDE and on the developers, typically you'll find they're using IntelliJ IDEA. Now, the difference between these two are that Eclipse is really easy to use, it's great for beginners, it's got various features which make it more suitable for beginners, in my opinion. Like, for example, when you're programming, it will actually highlight errors as you go along, by underlining them in red, which we'll see in a second. And it gives you very clear error messages, which kind of imply or kind of tell you pretty much how you should fix your code. So it's great for beginners, and it's very easy to use as well. For professional developers, it can feel a little clunky at times, and so a lot of professional developers tend to prefer IntelliJ IDEA. And again, that's for more advanced users. It's got much more power behind it, because it can also be a commercial product. With their Ultimate Edition, they've really made this product into something which you'd expect a proper Java developer power user to be able to get their money's worth with. However, that said, IntelliJ IDEA, it kind of does things behind the scenes, which you've got to be careful about if you're not a professional developer and if you don't know what you're doing. So it can kind of trip you up. So it's definitely for advanced users. But Eclipse is definitely the thing to start off with, and we'll see how to install that shortly. So that's the one we'll start off with here, and we'll see how to do that in just a moment. So let's have a look now and explore actually what features an IDE gives us. So the first thing an IDE does is it provides you the ability to actually type in your programs. So just like, for example, you might use a word processor like Microsoft Word to type up documents or reports for work, or you might use a spreadsheet like Excel to do your accounts or manage your home expenses, just like that. As programmers, we use an IDE to type in our Java programs. And this makes things much easier, as you'll see, because of some key features which an IDE provides. The main ones of these are syntax highlighting, showing you the errors you've made, and suggesting improvements to your code as you go along. Let's take a look. So let's look at the first of these items then. So what is syntax highlighting? This is one of the things that the IDE does for you. So what is syntax highlighting? Okay, so here's a chunk of code. It's a very simple piece of code in Java. It might look complicated, it's really not. And it basically defines class myapp, which has one method in it, which is the main method, the one and only method, which is going to do something. And what it does is it's going to print out the message, hello world. Now, if you see this program in an IDE, it would actually have syntax highlighting, and that looks like this. So basically here you can see that it's colored in some words, it's given some color to the words, and those words which appear to be in, I guess, kind of like a maroon or a dark red, maybe purple, depending on how your eyes are. But anyway, these words, like public class, public static void, those are basically colored that way to signify that they're keywords. They're reserved words by the Java language. So the use of this, for example, is if you maybe, for example, misspell public and miss out the I, then it wouldn't color code that into a maroon color, and you'd also have kind of a squiggly red underline as well, which will tell you that it's wrong. But coloring words in this way, coloring the text in this way, it just gives you that extra kind of quick visual guide to the meaning or the so-called semantics of that word or that keyword. Now you can see we've got other stuff which is still in black. So typically these are going to either be class names, methods, or types. So here we can see myapp is the class name, main is the method name, and the string array there, string with the two square brackets, that's a type. We'll see again the actual variable name, which of the thing we're passing in, these args value. A bit difficult to see, but that's actually in a different color again. That's how you can tell or differentiate inside that method between those two curly braces. You can see immediately whether you'd be working on a variable, which is passed into the method, against a variable which is outside the method, for example. You'll also see as well on the third line in where we've got the system.out.println line, we can see we've got the out is italicized, so it's in italics and it's also in blue. That denotes that that's a static data member, which is a bit advanced now, but it's just another way they can visually give you a bit of help. And inside you can see we've got the string which we're passing into system.out.println, which is a command that prints something to the screen. We can see we're passing in that string in quotes, and we can see it's color-coded that a nice bright blue for us. That's how we can immediately tell where the strings are in the method as well. That might not seem that useful, but the more complex your programs become, you really get to be able to kind of see the code better with these kind of features. but you won't tend to notice it too much when you start out though. So how does it show errors then? I mean, that's probably the most important thing you care about if you're a beginner. So here's an example. So this is Eclipse, and here we can see we've got the main method. We've got this application we saw before, and here we've got a class. So it says public class myapp, and you can see it's got a red underline underneath myapp, and there's a red kind of circle to the left of that, the line numbers. And if you look beneath there, you'll also see the same red circle with an X in it, and it says Java problems, 1 item. And it says syntax error on token myapp. It says a left curly brace expected after this token. So you can see here, it's actually telling you what to do. It's telling you that after myapp, which is the word it's underlined in red, it's expecting that you're going to put this opening curly brace. And in fact, the minute you put that opening curly brace, the red X would go, the red underline would go, and the problems, which you see there in this Java problems section, that list, that would also go as well and be clear. So that's one way it can show you that things are not quite right. And you'll see red X's everywhere contextually where that is. So if you see on the left-hand side, for example, this is basically the project structure. You can see at the deepest level, you've got this myapp.java. And then above there, you've got app, which is the package that's in. The package is just a folder for a class inside Java. And then above there, you've got source main Java, which is the folder which contains the actual Java code itself. And above there, you've got app, which is the name of the actual project. And again, as soon as you fix it, those will go. So the next thing we've said that it gives you suggestions, which are going to help you out along your way. And this is really useful for beginners. So let's take a look at this now as well. So now we've got a different IDE. This is IntelliJ IDEA now, which we're looking at. And just incidentally as well, you can still see we've got this red underline here. So you can see in the main tab here where it says app.java, we've got a red underline, and we also have it in the left-hand project pane as well. And that's because at the point, the exact instant where we're programming in this particular program, the syntax is incomplete because we've got system dot, then we don't have anything after that, and that's not valid syntax. It's not a so-called valid statement. A statement is basically the smallest unit of code that describes what you want to have happen. And that can either be assigning a value to a variable, or it can be invoking a method, calling a method on either a class or an object, or one of those things. So where this help comes in then, is actually where you're typing, when you're actually typing out the code, at certain points the IDE will offer you suggestions as to what you might want to type. So for example, when I type system with a capital S, that's referring to the class system, which is inbuilt into Java. It's a class that we get for free with the JDK. The JDK comes with hundreds of different classes that you can use to do various different things. And the system class is one of the most basic or foundational classes that you can use. And when we do system dot, that dot signifies that we're going to do something on that system class or connected with that system class. Specifically, we're going to access something on that system class. And we can either choose to access a data member. So if that class has a variable inside of it, which holds some data, which holds some value, or maybe an object or whatever, we can access that. We've seen that before with system.out. Out is actually a variable inside the system class, which stores a reference to a thing called the print stream, which is basically the way that we can print characters out or print data out to the display, if you like. But in addition to being able to access data with the dot, we can also invoke methods with the dot. So here we can see when we're doing system dot, we have several different methods which we can choose to call. So the first method, for example, in this box which appears below in this drop down, it automatically appears, by the way. You don't have to do anything. You just, as soon as you type dot, this will appear. And you can see we've got a method setProperty, which takes a key and a value. We've got another method arrayCopy, which takes some other things. We've got a method currentTimeMillis, method console, clearProperty, that kind of thing. What these methods do now are not interesting to us, but the main point is that as soon as you hit that dot, then the IDE offers you options for what it's sensible to call at that particular point. And that's the key point there. It's not just offering you any old stuff. It's actually offering you things that would only make sense to call actually there. So when the IDE offers you either suggestions like this or code fix suggestions, it can also fix code for you as well, which is pretty handy. Or if it offers you the ability to generate code, to actually program certain aspects of the code for you, which is also something else it can do. And by the way, all of these things together make a developer's life so much easier. You actually think programming is pretty difficult, but when you look at the power of an IDE and what it gives you and the amount of stuff it does for you automatically, it's actually not that difficult to do programming, to be honest. But anyway, the main point is that it also takes into account the context of where you're actually coding at that moment in time to be able to offer sensible suggestions as to things you might want to do. And furthermore, as you actually type out the method, if I started to type, for example, supposing I was going to go for the word console, for the method console, I would type the C. And what would happen then is it would automatically filter that drop-down box to just have the methods which start with C. So it would be clearProperty, console, and currentTimeMillis which appear. Then I type O, so now I've got system.co. Then it would just say console. And at that point then when it just says console, I can hit enter in IntelliJ IDEA or its tab in Eclipse, and it would type out the rest. to type out the remaining letters for me as well. It will also immediately put the parentheses there for me, so those brackets. And if I typed a method which actually wanted to take anything, which was designed to pass in any input parameters, it would also tell me what it's expecting. So for example, if I was invoking the array copy method, as soon as the left parenthesis is put in, so the opening bracket, it would come up and say, okay, what's your object source, for example. We don't need to know what the actual array copy method does. As it happens, it just copies arrays, as you might expect. Those are those groups of things of the same type we saw before, like when we saw a string array. Actually, like we can see the string array above with its square brackets. The point is, an IDE gives you all of these really useful and helpful functions along the way. So it actually makes developing programs much easier. You don't have to type, every single character painfully, piece by piece, that kind of stuff. It does it all for you. And even if you, for example, put in a left curly brace, so an opening curly brace, and hit enter, it will also put in the closing curly brace as well, so you don't have to worry about that. Little things like that. It'll also indent the code. So you can see here that on line 3, we've got the declaration line for the method, and you can see it's indented it. In other words, it's put space to push it in from the left there. That's so we can see that visually that's a method. And similarly, inside the method, on line 4, when we're starting to write a collection of statements which would comprise this method, we can see that again, it's indented it. And that means that visually we can see now that any statements or any lines we have from line 4, which are inside of these curly braces, they're going to be very kind of visually clumped together or grouped together so that we know that that's the implementation of that method. Yeah, that's another thing that an IDE will do for you. The other thing an IDE allows you to do is to actually compile your code. So just like before when we did the quick demo and we were compiling the Java code using Javac in the terminal window on the Mac, and you remember Javac then took that Java source code, compiled it, and turned it into Java bytecode, which could then be run on the JVM. But when you use an IDE, this is done automatically for you, and not just for one file, for multiple files that might comprise the project. And typically what you'll find is that an IDE will actually compile for you continually as you're actually developing the program, highlighting any errors along the way as well, and suggesting code improvements you might want to do. Now, typing your program in and compiling it is all well and good, but of course you need to actually run the program as well. And that's another feature that an IDE allows you to do, to actually run your program, which is sometimes known as executing your program. And usually in doing this, it'll also show you inside the IDE itself any output that the program returns, which is also very useful to have everything in one place. And finally, one of the best features of an IDE, in my opinion, is the ability to actually debug a program. So as programmers, we write program code, and obviously we're writing program code because we're assuming what we're writing is actually going to work. But more often than not, it doesn't work. Or at least if it doesn't work completely, there might be a few issues with it which we've got to try and fix. And the best way of fixing those is actually to run the program in slow motion. It's the best way I can think about describing it, but this is what you do pretty much when you're debugging a program. It allows you to go through what's known as step over each line of program code as it's being executed. And then along the side of it, you can actually see what's happening to the other areas of your program. So, how do you use an IDE? What does it actually look like when you're programming properly for real, putting together a real program? Well, it looks like this. First of all, you're editing the code. So you're inside the IDE and you're typing in the program code, which you think as a programmer is going to do what you want it to do. So that's the first thing you're going to do. You're going to edit the code. And then afterwards, at some point, you're going to compile the code or build it. Now with Eclipse, it does this automatically for you as you go along. So it's always compiling code for you automatically. But if you use IntelliJ IDEA, for example, you actually have to trigger this because you're in control of when you want it to do the compile or to do the build itself. But nevertheless, you're typing away, and in the case of using Eclipse, it's compiling the code as you go along. This means that at some point you're going to see some errors. So unless you're doing everything completely perfect from scratch, you're going to see some errors like those squiggly underlines we saw, the red underlines and the red crosses, that kind of stuff. And when you see those errors, of course, you're going to have to correct them. So that means you're going to go back, you're going to edit your code again. When I say go back, you don't physically go anywhere or return anywhere. You're still just inside the IDE, so you're just typing things out in Eclipse, but you're just happening to notice red, or red crosses, red underlines, or whatever, which is showing you so-called compilation errors. In other words, problems with your program that you have to address because it's not compiling. And that's happening because the compiler, the Javac compiler, is doing that for you behind the scenes. So then you re-edit the code to fix those errors, and then at some point, of course, you get to the point where you have no more errors, you actually have the complete code which comprises your program, and at that point, you're done. Because then, you can finally run the program itself. So that's pretty much what we go through as programmers when we're doing this process of programming, coding. So, now we know what an IDE is, we know what features it's got, and we know how to use it. Let's jump in now and install Eclipse, which is the best IDE you can use if you're a Java beginner. Let's jump in. So if we go to Internet Explorer again, this time if we type in Eclipse, here we can see we're at the website for eclipse.org. It's the first thing that pops up, and we're just going to download Eclipse IDE. So just hit the download button here, Again, you've got a choice of which operating system you're going to use. We're on 64-bit Windows. So here we can see this x86 64, which means it's compatible, by the way, for both 32-bit and 64-bit versions of Windows. That's fine. Click that. And then we'll just hit download. Again, same kind of thing. We're going to save it. Doesn't take too long to download as well. Now we can see it's completed. So if we just go to open folder, we can close this now. We can see here we've got the Eclipse installation. Now, if we double click this, because we set that Java_home environment variable before, Eclipse now knows where to pick Java up from and how to run. So you've got different options here. We're going to choose this one. And we just install, accept the agreements. And now it's actually downloading that particular version of the Eclipse IDE onto your local machine. And it might take a while to download, but that's fine. You can see now it's downloaded. So if we just do launch, notice as well it's also created a shortcut there on the desktop as well. The first time it launches, it might take a little bit longer. That's fine. We'll just accept this as the default for now. Launch again. And now here we are. We're inside Eclipse. Just close that. So this is the Eclipse welcome screen. And you can just hide this. And close this panel here. And then at this point, we're all set up. We've installed Eclipse, the IDE for Java, and we're all ready to start creating a new Java project. Now you know all about IDEs, and as you can imagine, programming isn't actually as bad or as complex as people would imagine when you've got a tool as powerful as that at your disposal. And we'll be seeing how to use an IDE in the next video. We're going to look at Javacode in detail for the first time. So we're going to start with an overview of the key constructs. Those are the key kind of things you have to write to be able to develop your Java programs. And then we're going to pull it all together by having a live coding session in Eclipse to program a very simple program in the IDE. Let's jump in. So let's just take a look at actually what's inside a Java application then. In other words, what are the components we'd expect to find inside a Java program itself? So first up, we have a class definition. And this basically is the main unit of code that you create in Java. So when you write a Java program, pretty much you're writing these classes, which can then be assembled into objects. And then how the actual program works is that these objects can have methods invoked on them. A method is like a chunk of behavior which you want the object to do. That method typically will cause an interaction with another object, or it'll cause the object itself to somehow change its state. In other words, to change the data that's actually inside the object. So this might seem a little bit abstract for now. Don't worry about it too much. Don't forget that we're just actually looking at what the high-level pieces are for now, and we'll go into actually how they work a little bit later on. So first off, yeah, we have a class. And how you declare a class in Java is that you have to use this kind of syntax here. So when we say syntax, we mean basically the sequence of words you've got to use, whether you have to use any special symbols, like for example, you can see here we've got this kind of like curly bracket thing. This is known as a curly brace. So you've got a left brace there at the top after the word myapp, and you've got a right curly brace at the bottom, you can see. That's basically the syntax. It's a combination of words and symbols used to define the class of the Java compiler. Because don't forget as well, it's the Java compiler, that Java C program we saw, that's going to be responsible for taking the source code that you write, taking the Java code that you write, and then producing a bytecode file out of it. And because of this, it needs to follow a very well-defined format of how you present things. In other words, you need to speak its language. You need to speak the language of the compiler. And that's basically what you're doing when you're programming in Java. You're speaking the language that the compiler understands. Writing your program in Java, so it can then be compiled and into bytecode and run on the JVM. So yeah, so here we can see we're creating a class. The class's name, all classes have a name, and the name of this class is myapp. So you can call a class whatever you like to call it. It's entirely up to you. And typically you'll call a class, give it a name that is based on the actual thing that you're modeling. And in this case, a name like myapp, for example, would expect maybe this is like a class which would be the kind of starter class, if you like, which starts off your Java program. So in other words, it's kind of like, think of it as like the main class, or the top level class, if you like. After all Java programs need to start somewhere, and they start with a method which contains the behavior to start the application, and that method needs to be defined ultimately inside a class. So we can imagine that this class here, myapp, is a class which effectively contains your application. Okay. Now how we actually define a class myapp is we use the class's name, which is myapp, as you can see there, and we can see it's got a capital M and a capital A. That's because in general with Java, when you're defining class names, you capitalize the words that make up the name of the class. That's why it's capital M and capital A. And immediately before this, we've got a word which is class. And that's because in Java, when you're defining something, you have to tell the compiler what it is you're defining. So you're defining a method, or a class, or a variable, whatever else it might be. We'll come across these things a little bit later on, but for now, just know that to create this class, you must at least have word class, then followed by the name of the class. And then, of course, inside the class itself, you need to actually give the code which you want to go inside the class. So in other words, you need to give the methods which define the behavior of the class. You need to define those inside the class, and you also need to define as well the data that it's going to hold. So a class in general in Java, it holds methods, which will tell objects what you want them to do, and it holds data, which will tell objects data, or the state, if you like, which you want them to hold. And you need to wrap all of those inside these curly braces, which you can see here. So a class declaration in Java at least needs to have class, then the class name, then an opening curly brace, then the code you actually want to put in the class, and a closing curly brace. Now you'll also see this word at the front, which is public, and that's because in general, most things that you declare in Java can have what's known as a visibility modifier. And that's just a fancy way of saying how visible that thing, in this case a class, is going to be to other items or other things inside your program. And with this word here, public, it means that basically everything inside the scope of the program will be able to see the class myapp. We'll see this a bit further down the line when we code a quick class up in an IDE, but yeah, that's basically how you declare classes inside Java. Next up, we have these method declarations. So as we've said, in Java, classes contain methods. And a method basically is the program code, or rather it contains the program code of something you want to have happen. So here, for example, we've got a method called greet. Again, methods have names just like classes do. And again, we can see we've got the opening curly brace and the closing curly brace. So as you might imagine, inside these two things, you have the actual code that you want to execute whenever this greet method is called. In other words, the thing you want it to actually do, which is also known as the implementation of the method. And you'll see also again that at the front there, we've got this keyword again called public. So by the way as well, we have these things called keywords. So keywords are basically special words that you use in Java, which signify something special to the Java compiler. As we've said before, we've got public, that's a keyword. And public means that any other items in the program can access this particular thing, which in this case is a method. That means that if I have 10, 20 different classes inside my Java program, all of those classes will be able to see this greet method. That's one keyword. Void is another keyword, which we'll get to in a second. And we have class as well, which we've just seen before, which is the keyword used to declare a class. So coming to this void and the brackets, which you can see here. So after greet, after the name of the method, which is greet, we've got these opening and closing brackets called parentheses. And what you normally find inside these parentheses are you find the input parameters. So in other words, the inputs that this method can take. So a method in general, you want it to do something, and in order for it to do something, sometimes it might need to take, actually more often than not, it might need to take some specific input, some specific parameters we call them. So you'd place them inside these parentheses. Now if you just see parentheses on their own with nothing in them, then that actually means, quite logically, there are no inputs to this particular method. So here this method called greet, it doesn't take any inputs. So in other words, it doesn't need to have any values passed to it to be able to do its job. And the reason is because, for example, you can imagine it would just display hello world on the screen. And if it just displays hello world on the screen, it doesn't need to have an input. Conversely, if you wanted it to take an input, you could, for example, pass in a so-called string, which is a piece of character information, in other words, a word pretty much. And that string might be called name. And then you could say hello, and then the person's name. So you could use that so-called variable to be able to access the value that's passed to this method. We'll get to how we call methods, also known as how we invoke methods, a little bit later on when we get into the demo of how we can code some Java. But for now, just know that the parentheses enable you to pass to the method the inputs of that method, so the parameters that it takes. Now, if you pass things in, obviously there's a chance that you might want to pass things back out, and you can pass something back out by the word which goes before the name of the method, and that's that special void word we see here. So a void in this case is a special word, special keyword, which actually means don't return anything. So again, the case of the greet method, which is just going to display hello on the screen, it doesn't need to return anything. It doesn't need to pass anything back to another method that might have called it, because methods can call other methods. That's how Java programs work to get the job of the program done. And in this particular case, because it's just printing a single thing, which we'll just define inside the method itself, which is this hello world, a couple of words, it doesn't need to return anything to anybody else. So then you'd use this keyword void. Now, if you wanted to return something else, for example, you wanted to return the greeting itself, then you could replace void with the actual so-called return type. That's basically the type of the thing that you're returning. You could say public string greet, and that would mean that this method returns a string, character data we saw before. So a string of alphabetical characters, basically. Or maybe you want it to return something else. You could return an int, for example, which stands for integer. That could be just a number you're returning. You might return a date, if you're doing some kind of logic to manipulate the date on the calendar, that kind of thing. You can return an object as well. So you can choose to return whatever you want, basically. And also, similarly with inputs, you can also choose to pass in whatever you want. So again, objects, ints, those are numbers, strings, that kind of thing. Whatever you want to pass in, that's fine. You just separate them with commas. That's how method declarations work. Then we've got variable declarations. So here's a variable declaration here. Now, a variable is a place inside the program, which is kind of like a storage area. You can think of it as being a box. And inside that box, it's going to hold some piece of data, some value that you want to assign to this variable. In other words, put inside the box. So here, for example, we've got string recipient name, and you can imagine that might have a value assigned to it, which is your blogs, for example. Maybe this might occur if you were writing some logic to process an order, for example. On a website like Amazon, you imagine Amazon might have some kind of order processing Java code there. You could also store number. Again, this is an integer, it's a whole number. So number of items, for example, you might call num items. And here, by the way, as well, you can see that the convention, that means the pattern or the rules you have to stick to, the convention we're using to use as the name for the variable is slightly different from that with a class. So here, it doesn't start with a capital, it starts with a lowercase. And that's nice because it means that we can, just by looking at two items, class name or a variable name, we can quite easily tell if we're working on a variable or if we're working with a class. That's the reason for that. And finally, you might have shipping address, for example, and that could hold a reference to, that means the actual type of the thing that's inside the box. That's the thing which comes first. So in all of these cases, you'll see the first word, the keyword which you have, is basically the type of the thing you're storing in the variable. So string recipient name, so we're going to store characters in there, character data or words, alphanumeric characters. Int num items, here we're storing in a number, an integer. Okay, so that means that we can't, for example, assign a person's name to num items because that won't fit inside that box. That box is just designed for numbers. It's not designed for strings. Similarly, recipient name, we couldn't assign the number 2042 to recipient name because it's expecting characters, character data. And then the real power of object-oriented programming, which Java is based on, is that you can then start to work at higher levels. You can start to compose things together. In other words, build them together with building blocks. So here we can see we've got shipping address. Now, shipping address, its type of the thing that it holds is an address, right? And an address can be a class which is defined elsewhere in the program. And that address might also have other items in it. It might have a string, which is address line 1, another string, which is address line 2. Maybe it might have a zip code, which is of type zip code, and zip code itself could be a class. And maybe inside the class for zip code, it also has, in addition to the actual numbers and letters that it's holding, the data that it's holding, just like we're defining data here, in addition to that, it might also have a method which can validate a zip code passed in. So when you try and create a zip code, for example, out of a string, so you pass it a zip code, it might, on creation of that string, also invoke a method to make sure that that string is valid. So in other words, it's a valid zip code. And you can put that kind of logic in these objects, in these classes, which we'll see. Now, where do you define variables? You can define them either inside a method, or alternatively, as we can see here, you can define them inside a class. And when you define them inside a class, you typically find them grouped together like this. And you'll also see another modifier, visibility modifier or access modifier, which we haven't come across yet, and this is private. So just like we've seen public before, which basically means that anything in the application can see that other thing, we also have this other keyword called private, and that means that only the thing that holds these variables can see those variables. For example, if these were in a class which is called order, so imagine we've got some kind of order class which we've created to hold the information when somebody makes an order on Amazon, for example, if we were doing some kind of website like Amazon, then maybe we want to have the recipient name, in other words, who's going to receive the order, the number of items, how many things they're actually ordering, and the actual shipping address, so where we need to send it. We'd have other things as well, of course, like, for example, the thing that needs to be sent. That's obviously not on here, but this gives you an idea. Now, when we have these items of data which are inside the order class, we're going to keep them private so that it's only the order class who can operate on these values. And the reason for that is it just keeps things nice and tidy, because if these were public, it basically means that any other class in the application could start meddling with and interfering with these data values. And then you can risk the so-called integrity of the program. So a nice thing about object-oriented design, object-oriented programming, is that you can so-called encapsulate, that's the word here, encapsulation, encapsulate the data that's inside an object, inside the object itself. You can think of this pretty much being like, order is like a box, and it has three other boxes inside: string, int, and address, recipient name, number of items, and shipping address. And it's only the order class itself which can see and operate on these values. We have two items to objects or classes. That is, we have data members, which we can see here that that's actually holding the state of a given object. But we also, in addition, we have methods, as we've seen as well. So you could imagine basically an order class might have some behavior attached to it, which we've programmed, which we call dispatch. And so you can imagine that at some point in the program, another object, perhaps when we've actually received the cash or entered our credit card details, or rather received the credit card details from the user, would then invoke the dispatch method. And inside the dispatch method, we'd have the code to actually send the order. And maybe that might return back something as well. So for example, it could return an order reference, which might be just one big long number. And so here we can see another so-called data type, which is long, which basically means like a number which is much bigger than you can hold inside an integer. Don't worry about that too much for now, the different types that you have in Java, but just know that classes have two things. They have data members and they have methods, and they're defined like this. So going back to the idea before where we have a first class or a primary class or the main class, if you like, which actually starts an application, how does that work then? Well, that works with something called a main method. So here we can see a main method, and it looks a little bit more complex than the format of the other methods that we've seen, but it actually follows the same syntax. So here we can see the name of the method is just before these parentheses. It's called main. That's the name of the method. Inside the parentheses, we can see the input parameters to that method, which is always the same. It's basically a group of strings. This group is called an array. It basically means they can pass in multiple strings or multiple character data to that method. That's what those two square brackets mean after the string word. Now inside the code of the method, if we wanted to access those, we'd access them by using the word args, which is basically the name of that array that we can use inside the method code to be able to access the inputs that have been passed in. Now to the left of main, we've got void, which we've seen that means it doesn't return anything. And indeed, there's nothing that it could return. There's nowhere it could return any data to, because it's just going to be invoked from when we run the JVM like we've seen before. When we do Java and then the class name, what the JVM does is it basically looks for that class, looks for a main method inside that class, which is this one, and then runs it. But because nobody's calling it besides the operating system or beside the JVM, or rather the JVM, it doesn't need to return anything, so it returns void. Right at the very front, we can see it's public. That means that anybody can call it, which is useful if you want other classes to be able to kick off the program. But in general, you don't really care about that, but nevertheless, it's public. It makes sense for it to be public because it's the main method. And finally, in between public and void, we've got this other method called static. And what that means, that's a special keyword again, that basically means that this method can be invoked, it can be run, but it doesn't have to be invoked or run against an object. It can just be invoked as is against the actual class which contains that method. We'll see that later on, so don't worry about that for now. And you can see as well, of course, we've got the implementation of the method we'd have between the opening and closing curly brace there as well. So let's see how we can put it all together into a Java program now by jumping over to the IDE and putting it all together. So yeah, let's jump in now and give you a quick demo of how we can actually use the IDE. So we're going to use Eclipse for this. And it's basically just to give you a kind of an idea, kind of a walkthrough, basically of what typing some Java code into an IDE looks like. So we'll see how we can type in code, features of the IDE, how the builds the code, how it compiles it, and how we can run the code too. Afterwards, we'll have a look at how we can actually debug code. Let's jump in. So by the way, I'm on a Mac for this, but don't worry though, because actually as it happens, Eclipse and IntelliJ IDEA, they're both applications which are programmed in Java. And so because of this, it means that they're pretty much the same to use on both platforms. So you shouldn't have any difficulty in understanding me showing you this on Eclipse on a Mac. If I jump in now, and I just click this Eclipse. So we'll just accept this as the default. That's fine, just do launch. So if we just double click this, maximize it, and get rid of this screen. And here we can see we're in Eclipse. And here we can see we're actually in the so-called Eclipse Workbench. So you'll see here that in the main pane, we don't have any program code yet. That's because we don't have a program. Specifically, we don't have a project, in fact, which is where we actually put our program code. In order to write a program, you need to have a project. So that's the first thing we're going to do. So let's jump in and create a project together. So there are different types of projects you can see over here. I'm just going to go into this one and create the simplest possible type of project, Java project. If I go down to next, project name, we'll just call it My App. We can accept the defaults on here. So just go down to finish. And it's going to ask us if we want to open up an associated perspective. This is basically a layout of the windows, which defines pretty much what tools you want to see and where you want to have them positioned. So I'll just do remember my decision and then do open perspective. And now we're in this so-called Java perspective, which means we can actually start doing our programming. So if we go over to here into Package Explorer and double click this, this actually shows you the project itself. So the project so far just has two things associated with it. It has source folder, which is where we're going to put our program code, and it has this JRE system library. This is basically saying which version of Java you're going to use. So I want to create a class, which is going to be the main program. So I right click here, and I go into new, and I could just go straight for new class. I could do that, but instead what I'm going to do is I'm going to create a package first. And a package is basically kind of like a well-named folder in which you can group different source files. That's not too important to understand now, but in general with Java, it is something that you need to do where you basically place classes into packages. Just keeps everything nice and organized. So I'm going to give a package name of com.javaeasily.demos. I'll do for now. And then I'm just going to hit enter. I don't have to use the mouse to click this finish button. If it's already highlighted blue like this, I can just hit enter and it saves me from having to move the mouse over there. So enter just picks out the default button that's currently highlighted. It effectively clicks it for you. And by the way as well, packages in general, they follow what's known as the reverse domain convention. That basically means that you take the domain name of the company that you work for. In my case, it's javaeasily.com. And then you reverse that. That will give com.javaeasily. And then after that, you can put whatever you like, which makes sense to your organization, just to be able to group the different classes that you write. So here, this explains com.javaeasily.demos, when we can put our program code and we'd put it inside the main method. And we can see here, this is this thing here, which starts with these two forward slashes. This just means a comment, so we can just jump to the beginning of the line. On a Mac, that's Command, and then the left arrow key. On Windows, that's just Home, and then just delete that. And at this point, this is a fully working program. It doesn't do anything because we haven't actually got an implementation. We haven't got anything, rather we haven't given any instructions inside here, which we want the program to do. So now if I just right click in here, now I can create the class. I go to new class, and we can see here it's going to create it in the source folder. It's going to create it in this package here that we've just created. Now I just have to give the name of the class. So I'll call it my app. And also there's some extra options here which we don't really care about. Apart from this one over here, we tick this, it's also going to create that standard main method, which we said before kicks off the Java program. So we'll just do that and click finish. Now we can see we've got our first class, my app, where we can put our program code, and we'd put it inside the main method. And at this point, this is a fully working program. It doesn't do anything because we haven't actually got an implementation. We haven't got anything, rather we haven't given any instructions inside here. So let's just plug in a line now just to print out our message. So to do this, we use the system class, which is part of JDK. And you'll see here that it's in the java.lang package. So that's one thing to know about Java, that any classes which are in the java.lang package, they get what's known as imported automatically for you, which means that you don't have to explicitly declare that you want to bring some class in to use it. Now we haven't looked at imports, but basically if you want to use class from another library, typically what you'll do is, between the package statement at the top on line 1 and the class declaration on line 3, you'll use an import statement. And the import statement will be something like, for example, import java.util.list. For example, if you wanted to reference a list from the java.util package. Now, Java comes with a whole heap of different classes, which are inside various packages as part of the JDK, and you can have all of those at your disposal as well. But for now, just know that we've got the java.lang package, which is effectively being auto-imported for us. Anyway, so then I do system dot, and you can see here this is the compiler giving us helpful suggestions. So if I look in here, if I scroll up, you can see that it's not just one method or field it's given us a whole heap of them, a whole different array of them. So these are all the different methods or fields, these variables inside the class, that I could actually access now. So for example, we're going to do this one here, which is out. So I could either type out like that, and as you can see, as I typed each character, if we just back up a little bit, as I type each character, so I type the O first, you can see there that it's actually matching and filtering the list based on that specific letter. I do U next. Now you can see it's got two options it can suggest for me. I want this one. Also as well, another really nice thing in Eclipse, you'll see on the right hand side there of the method and field suggestions, they've got this kind of like documentation panel. And this is actually showing you the so-called Javadoc, that's the Java documentation, for this particular field on the system class. So it's really nice that you get this kind of help, specifically when you're starting out as well. So you can then go over, for example, just have a read of it. You can scroll up and see what it's telling you. You can see they're saying there's some other methods that you could also choose to look at as well if you wanted to. We're not going to look at this in detail now, but just know that it's there to help you. And it's another one of these nice aspects of Eclipse that you have, which again makes Eclipse, in my opinion, the best IDE for beginners to start out with. That said, if I hit enter, now I've got this system.out reference, which is a reference to the print stream, which enables us to be able to write a message to the display. Now if I press another dot here, you can see we've got the same kind of thing again. Only this time, instead of it showing us, like it did before, methods or fields which were available on the system class, now of course, we're not accessing the system class anymore, now we're accessing the print stream. Because out, which is a field inside the system class, the actual type of that is a print stream. So that's how it works in Java pretty much. Whenever you have a dot it's the thing immediately to the left which is being referenced. And again, when you press the dot, you can either access fields on the class or object, or methods on the class or object. Another method I want is called printLine. So if I start typing printLn, you can see here we have a whole heap of methods which all appear to have the same name. And that's because they're the same method, but in Java you can specify a method multiple times with each method declaration accepting different types of input. And that makes the method very flexible. So for example here you can see we can choose to pass in, I use my arrow keys, an integer. That's the type for those whole numbers we saw, so numbers like 3, 17, 4072, that kind of thing. Oh, we could pass in a string. So that's where we have a message which is in quotation marks. So yeah, that's a very flexible feature of Java, and it's known as method overloading. If I now press enter, then you can see it's automatically selected that particular method for me. It's also put the parentheses round as well. And now it's also saying, okay, well, give me a string, which you can see there above. If I just put quotation mark, hello world, the quotation mark, and at this point, you can see that we've no longer got any red underline squiggly underlines, nor do we have any of those red crosses in the circles. And that's because now this particular class is valid Java code. In other words, it can be compiled down to bytecode and then executed on a JVM. If I move this cursor away, you can see as soon as I moved it to the right, by the way, I'm using the arrow keys to do this, so your left arrow moves you one way, right arrow moves you the other way. So as soon as I moved it to the right, because we were outside of those parentheses, then Eclipse noticed that there's no point in giving us that little helpful tip which told us what it was expecting, which was a string. So at this point, we've got a valid program. Now, if I just save it, because we've got this star here, which means we haven't saved it, so I'd do Command S on a Mac, Control S on Windows, just save that. And then if I right click on here, on the class itself, and do Run as Java Application, and then we'll see here we've got this new tab which has popped up called Console. It says that the program's finished. That's what terminated means. And you'll see underneath, we've got a message, that string that we passed to system.out.println, which said hello world. So you can see here a few things. Number one, it's allowing us to type in the program code. And with that, it's giving us syntax highlighting, showing us when we make errors, and it's providing helpful suggestions. Number two, because it ran the program, that means it must have compiled the program down to bytecode. So it must have invoked the Java C compiler somewhere along the line, which we'll see in a second. And finally, number three, it's actually running the program for us as well, which means it's passing that compiled bytecode, the JVM. And we can see here, in fact, this is the actual command that it used to do that when it launched the JVM. Now, just to show you as well, we actually do have a class file which was generated. That's the bytecode, don't forget. If we go up to Window and go to a new view, we go down to Navigator, then you can see here, this is actually showing us all of the files which are in the project. So this panel here, this pane here, is just showing us basically the items that are relevant to our source code. It's just purely focused on showing us the relevant things. It's actually shielding things from us that we don't necessarily need to see on a day-to-day basis, which is kind of good, because then you can just focus on exactly what you need to focus on, which is the actual code and making that work. But you'll see we don't have, for example, the myapp.class file, which we'd expect. It is there, it's just in a separate subdirectory. So if we go down to the Navigator view here, you'll see that this is the actual real project structure with all of the files. And you'll notice that inside our source folder, we've got source, com, Java easily demos, myapp.java. By the way, that's one thing to bear in mind as well, that the package that you place a class into actually gets turned into a directory structure like this. So you can see this is like com.javaeasily.demos, which corresponds to com.javaeasily.demos up there. Anyway, that's where the source file was. And similarly, if we go into the bin subdirectory, we'll see the same structure. So we'll see com.javaeasily.demos corresponding to com.javaeasily.demos, because Java classes in a specific package compile down to class files which are in the same package, so therefore it has the same folder structure. And inside there you can see we've got myapp.class, which corresponds to myapp.java here. So myapp.class, myapp.java. So if I close these off, and this one too, and you'll see there are also some other files and folders there as well. We've got .project, .classpath, and .settings. These are folders and files for Eclipse's internal use. We don't need to know about those for now. So if we just come out of this, and so we'll just see now how a method works, for example. So I can actually take this piece of code here, I can do this, I can actually do a special advanced procedure, which I'll give you a sneak peek into, called refactoring. So if I just right click here, then I go down to this menu here, refactor, we can use this one here called extract method. If I click this, now what this is actually going to do is it's going to take this statement out, or printing hello world, and it's going to push it into its own method and replace it then with a call to that method. So this is a great way how we can, first of all, reinforce our understanding of how methods are declared, but also we can actually see how they're invoked as well, how the method's actually called, in other words. So it's asking me to give it a name, so I'm going to call the method, say, greeting, for example. And here you can see we've got these access modifiers we were talking about before. You'll recognize private and public earlier on in the course. We'll just leave it for private for now, that's fine. Because we're only calling this method from within this class, it's okay that it's private. It'll still be visible to the method from which it's called, as we'll see. Then here we can see we've got a preview of the signature itself. And the method signature is just a fancy way of saying what the method declaration looks like, with all its combination of modifiers, return types, method name, and input parameters. So now if we click on OK, you'll see that just like that, we've got a new method. So this is how you actually call a method. You just basically use the method name, and then the two parentheses there, which matches the method name here, and the two parentheses here. And here we can see the method declaration itself. So if we rerun this now, it shouldn't change anything. We just right click again, go down to run as Java application. Yeah, it hasn't changed anything. So you're probably saying, well, what's the point in rerunning it? Well, the point of rerunning it is just to make sure that after we did that so-called refactoring, we're just rerunning it to make sure we didn't break anything. Because in spite of the fact that we didn't actually have any red error marks, we did that, it's still possible that we might have some kind of errors or whatever, depending of course on how complex the code refactoring you were doing actually was. So let's quickly demonstrate now how we can actually pass parameters. So if I just go up here, let's supposing I want to pass a parameter here, such that instead of saying hello world, it'll say hello and then the person's name. In order to do that, let's put in a parameter here. So we use the type of the parameter, which is going to be a string, because it's going to hold textual data, so character data, so alphabetical characters, that kind of stuff. And we give the variable a name, which coincidentally will also call name, because that makes sense. We're passing in the name of the person we want to greet. And once we've done that, we can delete this and replace world with the variable that we passed in. If we pass in Matt, it would say hello Matt. If we pass in John, it would say hello John. Now you'll notice over here, we're getting this red squiggly underline again. And the reason is, of course, because we're not actually passing a name now, because we haven't adjusted this method call to take into account that we're now passing a name here. And if we didn't know that, give you another demo of how helpful IDEs can be. If we just click on this X over here, we can see that it's offering us some ways to fix this situation. It's saying we can either add an argument, that means pass a parameter, to match the fact that the method takes a string parameter. That's what we're going to do, by the way. Or alternatively, it's saying, do you know what? You can actually change the method itself to remove parameter. And both of those, if you think about it, would fix the situation. Just press escape quickly just to explain this. If we pass in a parameter here, which is a string, it will match this, which means it would then work. And remove that red X, squiggly underline. And similarly as well, if we removed this parameter here, then we'd have a method which doesn't take any parameters. That would also work, which would again remove this squiggly underline and the red X. So both of those options are perfectly viable. If we go back on again by clicking it, we see there's another option as well, which is to create a completely different method which doesn't take a parameter at all. And at this point, you'd actually have two methods with the same name. One takes a string, one doesn't. That's that concept of overloading I mentioned a few moments ago. So yeah, all viable options which the IDE is offering you. All easy to understand and simple to digest as long as you read actually what it's saying. And you'll notice as well that on the right hand side, where we saw the documentation panel before, which gave us helpful documentation, this time we've actually got a potential preview of code that it could write for us. Now it doesn't know to who we actually want to say the greeting to, whether it's Matt or John, so the best it can work out, fancy word for that is infer, the best it can infer, which we usually say, the best it can infer is just to say, well, okay, don't really pass anything past null. We won't go into null and what that is. It's outside the scope of this lesson, but it's one solution. And similarly as well, if you click this one, it's again giving you a preview of what that would look like. Of course, it hasn't fixed the entire code, because even if it did that, and it removed that name parameter, you'd still then get an issue here, where you'd be referencing something that hasn't been passed in. But it's enough to give you an idea of what you might want to do and the way the IDE would adapt the code for you. So anyway, we're going to double click here now, and as it promised, it's putting that null placeholder for us, which meant that at least now the code compiles, now instead we're just going to replace that null value with my name, for example. And if you just press escape afterwards, it loses that box highlight so you can see the code a little bit better. So now if we run the program, and to run as Java application, we'll see that it's doing something else helpful. Because we didn't save that before, you see there's a star there still. Now it's saying, oh, do you want us to save the resources for you as well? Do you want us to save the source file? Yes, I do. I'll even say always save the resources before launching, so it always overwrites, and do OK. And now we can see it's saying hello Matt. So that's an overview of how you can pass parameters into methods. Now to show you the idea about debugging that we were talking about before, I could right click and do run as, that will just run the program, but I can also do debug as, and I can debug the program. Now before you do a debug, or before you launch the debugger, or rather the IDE when it's in debug mode, you need to set a thing called a breakpoint. And that's basically where you want the program to stop, that is to stop running at that specific point, so you can effectively take a look around. So if I go up to here, for example, if I double click in the margin, just to the left of the line numbers, that's how you set a breakpoint. And this means that now, if I right click and do debug as Java application, it'll first of all ask me if I want to switch to perspective. I'll say remember my decision, and yes I do. Go to the debug perspective. Now this is going to change the windows slightly and the panels that we've got. So that now this particular perspective, in other words this arrangement of windows and panels, is geared towards debugging. So in other words, like looking through the code, and actually it's called stepping through the code, see everything that's going on. Just notice the fact that what we've actually got here now is the program is suspended just before it executes this line. So this, when it's put this highlight in here, it's highlighted this line, what that means is I've stopped here just before I execute this line, before I run this particular line or do this method call in this case. And it's effectively saying, well, what do you want me to do? It's not going to do anything unless we do something at this point. What we can do is we can what's known as step into the method. So this is the sayGreeting method, and it's calling this sayGreeting method. So if I go up here to the run menu, we'll see that the first few menu items here are effectively commands that you can do at this point. So I can choose to do step into, which is F5, which will go into that method, or I could do step over, which is F6, which goes over the method. I'll just show what those mean now. So if I click back here, press F5, you'll see that now it's gone inside of this method call. So now it's inside this method here, which we have. You'll also see a few other things now as well. You'll see that in the right-hand pane, we can actually see the variables that are available now. So this method has a name variable which is passed in. If I hover over it here, it actually tells me what that value is Matt, which is really helpful. And you'd only get this in the debug view, by the way, because this is now running code. It's not us programming it, it's the JVM running it now. And you can see over here we've got variable name, it's set to Matt. And then over on the left-hand side, you can actually see what's known as the call stack. And that's basically showing us the sequence of calls that have been called. And it's kind of funny, but it goes from the bottom up. So it's saying basically the first thing that it ran was the main method in the myapp class, which happened to take an array of strings. That corresponds to this one here, the main method in the myapp class, which took an array of strings. Then it got to line 6. You can see here line 6, which is this line here. And now it's at a breakpoint on line 10 in the sayGreeting method, which takes a string. So here we've got the sayGreeting method, which takes a string. And this is line 10, which it stopped at. And you can see line 10 here, line 10 here. It's showing you very accurately what's going on. So like before, when we stepped into the method, if we had a method we wanted to step into the code of, with F5, instead we can press F6 now, which is step over. So when you step over something, it just goes to the next line. So if we do F6 now, you can see it goes to the next line. Now if we do step over again, you can see it jumped out of that method because it finished that method. There's nothing else it needs to do there because it got to the end closing brace, that right-hand curly brace you can see there. But also notice what happened as well. The name variable which we had here before, that's now gone. That's because that's no longer what's known as in scope. In other words, it's not available to us anymore because in this method here, there isn't a variable called name. That was only in that method here, and only specifically for that method at that specific point in time. But now that method's gone. And we can tell that method's gone as well because if we look back over here to the call stack, we no longer have this sayGreeting method here. We no longer have it on the call stack. And in fact, now we've progressed from line 6, which it was before, to line 7, which is this one. So finally, if we press F6 to step over, at this point, there's no more code to run. The application's finished, terminated, and we've finished what's known as our debug session. You can also do various fun things as well when you're in a debugger. For example, you can change the values of things. You can choose to return from methods early. You can choose to throw exceptions. We haven't seen exceptions, but that's a way of being able to say there's an error in the code. You can do things like that. And it really enables you as a programmer to be able to really go in deep to your code and understand at a very deep level how it works. Now, obviously, this program is trivial. It's like the easiest program we could have written, to be honest. And Java programs, they get, of course, increasingly more complex. Although don't worry, because it's always manageable complexity because of the simplicity of the syntax of the language. That's the combination of keywords and symbols and that kind of thing. It's quite easy to get the hang of once you ever play around and practice a bit. But the point is, though, once you take your programming to the next level, you start developing more complex Java programs, that's when you really start to see the power of a debugger. So yeah, debuggers in IDEs, an essential tool to have in any programmer's toolkit. So that should have given you a nice overview of the main moving parts we have in Java programs, and also a sneak peek into what it's like to actually use an IDE to do some Java programming. And as you can see, once you know what you're doing, it's actually not that complex after all.